In this video, we focus on example 17a and b. In this example, we need to use the following concept. Recall that the polar form of a complex number can be written as r bracket cos theta plus I sin theta, which can be expressed as r cos theta plus I bracket r sin theta. The main concept that you need to know is that the term before the addition sign without the I, that is the real part of the complex number. It is actually the x in the x plus iy form. The term after the I is actually the imaginary part of z, which we know is the y, value of y in the x plus iy form. So this key concept is very important when we are answering questions that specifically require the real and imaginary part of a complex number. So let's see how we apply it in this question. In example 17a, we are given the modulus of z and w as z mod z is 2, mod of w is 4. We are also given argument of z as negative 3 power 4 and argument of w as power 4. So in example 17a, we know that the real part of z can be written as r cosine theta. So since the modulus of z is given as 2 and argument of z is given as negative 3 pi over 4, we can write the real part of z as 2 cosine negative 3 pi over 4. Now, to simplify this, we consider the diagram with the angle negative 3 pi over 4 marked out. So we know negative 3 pi over 4 will be an angle in the third quadrant. Remembering our CAST, we know that in the third quadrant, cosine will be negative. Only tangent is positive in the third quadrant. So, bearing this in mind and knowing that the acute angle in this diagram will be having the size of pi over 4, and knowing that the cosine of negative 3 pi over 4 is negative, so we can say that cosine of negative 3 pi over 4 is negative cosine of the basic angle pi over 4. And this should give us negative 1 over square root 2. And it will simplify to negative root 2. In example 17b, we are asked to find the imaginary part of 1 over w. For this portion, we know that we need to work out the imaginary part of the complex number, so we need r sin theta. To work out the r, the modulus of the complex number 1 over w, we know that r of w, which is modulus of 1 over w, can be simplified as 1 over modulus of w. Knowing modulus of w is 4, we will have 1/4 as the modulus of 1 over w. That is how we get this value over here. For argument of 1 over w, recall that when we have argument of z1 over z2, we can simplify it as argument of z1 minus argument of z2. In this case, Z1 is 1. So we have argument of 1 minus argument of W. Now, argument of 1 is actually 0. As you can see here in the Argand diagram, the number 1 is over here. It's actually a real number, so we only have one unit. It has no imaginary part. So when we draw this vector from 0 to 1, the angle it makes with the positive real axis is 0. So argument of 1 is 0. So we know that argument of 1 over W will be the same as argument 1 minus argument W. That will be 0 minus pi over 4. So we have our argument negative 1, argument of 1 over W as negative pi over 4. Imaginary of 1 over W equals to r sine theta. So it will be 1/4 sine negative pi over 4. And when we simplify, we know that sine of negative pi over 4 is the same as negative sine pi over 4. Knowing that sine of pi over 4 is 1 over square root 2, we can simplify and rationalize it to be negative root 2 over 8. Thank you for watching this video.